In this video, we're going to talk about Section 8.2 in our book, Law of Sines. The Sohcahtoa right triangle definition we know, where sine is opposite over hypotenuse and cosine is adjacent over hypotenuse and tangent is opposite over adjacent, requires a right triangle. And the nice thing about law of sines is it does not. So it works in any triangle, not just a right triangle. So the law of sines says in any right triangle, these proportions are equal. The sine of angle A over side A is equal to the sine of angle B over the side B is equal to sine of angle C over side C. So let's see why it works the way it does. So here's a little bit of a proof. If we drop a perpendicular down from angle B to the opposite side and call that side length H for the height of that triangle, by dropping that perpendicular down, we get two right triangles. We have one on the left, I'm going to just outline it in green, and one on the right, which is over here in the blue. So using the right one, we can say that the sine of angle A, now we can use Sohcahtoa because now we do have a right triangle, is going to be H over C, and solving that for H, we get that H is equal to C sine A. So we put that aside for a minute and look at the blue triangle. In the blue triangle, we can see that the sine of angle C is opposite over hypotenuse, and solving that for H, we get that H is A times the sine of angle C. So those are the same h's, so that allows us to set those equal to each other. So we can say C sine of angle A is equal to A times the sine of angle C. Then if we divide through by the AC, then we can see that the C's will cancel here, the A's will cancel there, and we get part of our law of sines, that the sine of angle A over side A is equal to the sine of angle C over side C. And if we just rotated the triangle around and did it again, we could bring in sine of angle B over side B as well. So that's kind of a proof why it works. Let's see how we can actually use it, how you're going to be asked to use it in problems. So we will use these. In your geometry days, you learn 4 ways of proving triangles are congruent. Angle, 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 side, also side, side, and side, angle, side. So you learn in geometry if those 3 parts of one triangle are congruent to those 3 parts of another triangle, then that's enough to force the 2 triangles to be congruent, meaning that all their sides and angles are congruent. So when we know these pieces of a triangle, then the triangle is determined. There's only one choice for the other angle and sides. And so we can then solve for those. Now, it turns out that the pieces work out well in angle, side, angle, and angle, angle, side, that we can use law of sines, as you'll see. When we get different information, like side, and side, angle, side, it just isn't enough for us to be able to get proportions that we can solve. And so law of sines won't work, and we'll have to learn the law of cosines to deal with those. You don't really have to memorize that. You just, as we'll see eventually, law of cosines is considerably more complicated than law of sines. So generally speaking, law of sines is our kind of go-to method. We'll try that first. If it works, great, and if it doesn't, then we'll go, oh, shucks, I guess we'll have to use law of cosines and then go from there. So here we have some information. We know in this case that angle A is 29 degrees. I'm going to mark that in here. Angle B is 74 degrees, and side C, which is opposite angle C, is 8. So you can see this is an angle, side, angle information. We don't really have to worry about that. That's not a huge deal. We just try to set up proportions and go from there. Now, as we go to try to solve it, since we know two of the angles, probably the easiest thing to do is to find angle C first. And since we know all of the angles have to add up to be 180, we can subtract off the 29 and 74. So let's see, 29 and 74 makes 103, I believe. And if we subtract that from 180, then we get, I guess, 77 degrees. So that's going to be one thing that we know is that missing angle is 77 degrees. So now we can set up a proportion. So we want to use the only side we know, 8, and that goes with the angle opposite it, sine C. So we'll say the sine of angle C, which is 77 degrees, over side 8 is, and now we can pick whatever one we want. I'll just go alphabetical, not any particular reason. I'll go sine of angle A, which is 29 degrees, over side length A. Now we have a proportion, and we can solve this proportion for our one unknown using the fact that cross products are equal in a proportion. So A times the sine of 77 degrees will equal 8 times the sine of 29 degrees. I'm just multiplying the diagonals there. Then we solve that for A by dividing that sine 77 over. So that's going to be 8 sine of 29 degrees divided by the sine of 77 degrees. And then we can just go to our calculator. So I'm going to make sure that I'm in degree mode. I am. And so we can go 8 sine of 29 divided by the sine of 77, and I'm getting 3.980. So I'll call that 3.980. So now we have the A and the angle C, and we still have to find side B. So now I would use the ones that we were given. I just think they're going to be more accurate. So I would again go sine of 77 degrees over side length 8 is going to equal the sine of angle B, which is 74 degrees, over side length B. Again, we cross multiply. So B sine of 77 is equal to 8 sine of 74, and solving for B, we'll get 8 sine of 74 degrees divided by sine of 77, and I'm going to go to my calculator again and go 8 sine of 74 divided by sine of 77, and that's going to be 7.892, and we have successfully solved the triangle. We found, given the two angles on the side, we found the other angle and the other two sides using law of sines. So let's look at another one. So here we have side A, and so side A is, oops, I bumped that with my hand. Side A is going to be 8. I'm going to bring my pen back now. So side A is going to be 8. Angle B is 64 degrees. This will be side B. Angle C is 38 degrees. This will be side C. So once again, this time you can see that we have angle, and the non-included side. So we have angle, side, and you don't have to state that or anything. We'll just try to make it work, and we're using law of sines, and if it does, we'll proceed. If it doesn't, we're going to need to learn law of cosines. So the 8, let's see, let's find angle A first. So angle A is going to be, again, 180 minus the 64 minus the 38. So that's going to be, let's see, 64 plus 38 is going to be 90, 102. And that's going to make our angle A be 78 degrees. So I'm going to label it there. Now we can, and so this is the first part that we've solved for. Now we're going to use this, the ones we know. So we're going to say sine of 78 degrees over side 8 equals, and we can do whatever we want. I'm going to just go alphabetical and say sine of angle B is 64 degrees over side length B. So cross multiplying, we'll get B sine 78 is equal to 8 sine 64. So B is going to be 8 sine 64 over sine 78. And I'll take that to the calculator. 8 sine of 64 divided by the sine of 78. And I'm seeing 7.351. 7.351. So now we have solved for side B. And we still have to find side C. So I'm going to start again with the ones that we know. So the sine of angle A is 78 degrees over the side length A was 8 that we were given. And we can now do the sine of angle C, which is 38 degrees over side length C. So cross multiplying, C sine of 78 is 8 sine of 38. So C will be 8 sine of 38 degrees over sine of 78 degrees. Going to our calculator, 8 sine of 38 divided by the sine of 78 is going to be 5.035. 5.035. And so we have solved the triangle because we have found the missing side lengths. Okay, that's law of sines. Very good.